Okay, so first thing is, no matter how many times I check and recheck and recheck things, anytime I edit one of these and I move anything, some things disappear sometimes, not always, and I don't know where they go. It's not like they're in the wrong place. They're just gone, and even though I check it and it's still, I miss things. So this should be a big old fraction. This should be a big old fraction. So make sure and put that into the notes. It's on the reference chart, it's correct. On the notes, it was weird. Okay, thanks. All right, who saved your life? Oh, so why is it embarrassing? You got something? We don't know what it is. It's fine. Okay, so we're going to start by, so we have sum and difference identities for sine, cosine, and tangent. So I could be adding two angles together or subtracting two angles, and then this is how it actually all works out, because you're not always going to be able to know the values. So for instance, in number 1, my guess is you probably have no idea what the tangent of 5 pi 18ths is. I don't either, and it doesn't matter, okay, because we're going to use an identity to help us get it down to something that we can actually work. So I've got a tangent minus a tangent. And so on my tangent ones, this one, the numerator is tangent plus tangent. This one's tangent minus tangent. So I think it's this one, but make sure you look at the rest of it too to make sure it all jives. Otherwise, it may not match anything. So this is 1 plus tangent times tangent, so that all works, but you also want to make sure that if this is A and this is B, that this is A and this is B, and it all fills in just right. So since it matches that completely, this is tangent of A minus B, so this is tangent of 5 pi 18ths minus pi 36ths. Okay, and remember, you have to show your work on this stuff, okay? So then this gives me the tangent of, I'm going to need a common denominator. My common denominator here would be 36. So this is going to be 10 pi 36 minus pi 36. So this will give me the tangent of 9 pi 36ths, which is still maybe something that you don't know, but tangent of 9 pi 36, Abigail, what does 9 pi 36 reduce to? So I got my pi in the numerator though, right? Yeah, pi fourths, yeah, you got it. All right. And then tangent of pi fourths is something that we should know. Caitlin, what's the tangent of pi fourths? 1. You got it. And so our answer is 1. Thank you. Questions? Easy enough. You see how one way to use this, we're going to use it a few different ways. But all right, so then if we look at number 2, we've got sines and cosines multiplied together. So my sum and difference identities for sine and cosine. If you look at the sine ones, both of them start with sine times cosine, sine times cosine. Both of the cosines start with cosine times cosine. Okay, so since this one is sine times cosine, then cosine times sine, it means it has to be either the sum or difference of sine. And since this is subtraction, it matches with this. This is not what says, hey, this is a difference, because it doesn't all work. If you notice here, for the difference for cosine, there's addition. So difference means that it matches this exactly, and then this is what tells you it's actually a difference. So then I check and make sure this is A, B, A, B. I'm good. I feel like it matches this one exactly. So this is going to equal the sine of 13 pi tenths minus 2 pi 15ths. I'm going to need a common denominator. David, what would my common denominator be? You got it. So this will be sine of 39 pi 30ths minus 4 pi 30ths. So then that becomes the sine of 35 pi 30ths, which is probably not a value that you know, but that's okay, because we can Simplify that, and 35 pi 30ths reduces to what, Gwyneth? It is 7 pi over 6. Okay. Then sine of 7 pi 6 is something we should know. Corey. Sine of 7 pi 6. First of all, Corey, what quadrant would that be in? You got it. And is in the third quadrant, is sine positive or negative? Negative. Okay, then we just have to really worry about what sine of pi 6 is, and what's that? You got it. So it's negative 1/2. Okay. Everybody good? Any questions at all? Alrighty. So look at number 3, and I feel like that matches a tangent one, right? And there's addition in the numerator, so it matches this one, which means it would be a sum of the tangents. And I have AB, AB, it all looks good. So this is going to give me tangent of 48 plus 102. So that means that is tangent of 150 degrees. Now, we do pretty much everything in radians, but degrees could pop up every now and then. You should be, if you're 100% confident in your radians, then figuring degrees out really isn't that big of a deal. Because here's how I would do this. I wouldn't go and actually physically convert, which you could. And maybe you know your degrees around there as well. I would imagine most of you don't. I mean, I don't have mine memorized that way either. Those that do, it's just because you have that mind that kind of thinks that way, and that's okay. Keep it to yourself because we're jealous. All right, so tangent of 150. Here's what I know about 150. 150 is in the second quadrant, right? I know that this is 180. So if I want to get to 150, I would back up 30 degrees. Make sense? That's my thought process there. Okay, so then I think, well, I know what 30 is in radians. Like, you should at least know the first quadrant. I'm sorry, yeah, in radians and degrees. So what is 30 degrees in radians? Pi what? Pi 6, right? So that means I'm basically here and I back up pi 6. So this would be 6 pi 6. I back up 1 and I'd be 5 pi 6. Make sense? Okay, so this is equal to the tangent of 5 pi 6. And then the tangent of 5 pi 6 is something we should know. Nabil, what is the tangent of 5 pi 6?
I don't remember that part.
Okay, so what quadrant are we in?
We're in the second.
Okay.
Wait, yeah.
And in the second quadrant, is tangent positive or negative?
Negative.
And then that means I really just need the tangent of pi 6. That's one you definitely should know. What's that?
Repeat that.
Since I already know that I'm in the I'm in the second quadrant, so tangent's negative, all I really need to know is the tangent of pi 6. What's that?
Oh, I think it's square root of 3 over 3.
So my answer is negative square root of 3 over 3. And I'm done. We good? Thank you. Yes? Awesome. All right, so let's look at number 4. I have cosine, cosine, sine, sine. So that matches my cosine ones, right? And then this is subtraction. So that matches this right here. So cosine, cosine minus sine, sine means it is a sum of the angles. So this would give me cosine of 300 plus 15. Now, I know you're capable of adding that and writing down 315, but your first step is always substitution. If you just write down 315, you're like, where the heck did that come from? You write this down, it shows that you're actually substituting it into something. So your work matters for sure. And then that means that this is cosine of 315 degrees. So I would kind of think the same way around the circle, right? So 315, I'm pretty confident that is in the third quadrant because this would be 270 right here. This is 360. So it's, I'm not third, I'm sorry, in the fourth quadrant. I was thinking about it, right? I said the wrong one. Pretty confident it's in the fourth quadrant, not the third. So how far am I degree-wise from 360? 45. So basically I could go to 360 and back up 45 degrees. So what's 45 degrees in radians? Well, just 45. It's pi fourths, right? So just 45 is just pi fourths. And then if I get all the way over here to 2 pi, that's 8 pi fourths. I back up 1, and then I heard it. It is 7 pi fourths. So this gives me cosine of 7 pi fourths. Okay, that's a value we should know pretty quickly. All right, so Ivan, what is the cosine of 7 pi fourths? Square root of 2 over 2. Good. And we're in the fourth quadrant. That makes it positive. That's my answer. Okay. Any questions at this point? Alrighty. So that's evaluating, meaning we're actually going to get a number. When we simplify, we may actually, sometimes when we simplified, we got down to a number, but it's more often you're going to get like a trig expression of some sort. So let's look at number 5. And using this chart here. So even though you don't have to have these memorized, you should be familiar enough with them. So if you see something like what you have in number 5, you think to yourself, you know what, that kind of looks like something that's on my chart. Like, you know it enough to go, I think that's probably on there somewhere. So if you look on your chart, there's 3 sections. So the very bottom of the first section there is where your sum and difference identities are. So you go, all right, so it really looks like I've got cosine times cosine plus sine times sine. So I find that on here. That looks to me like it's cosine of A minus B. But remember to double check that you've got your A and your B here, right? So it is. So this means that this is going to be cosine of 2x minus 4x. Everybody understand where that's coming from? So that means this gives me the cosine of negative 2x. I should not have negative angles when I'm done. And just like you shouldn't have fractions and reciprocals and things like that. So I know what to do. I know I have something on here about negative angles. So when I look at my even odd identities and I can find cosine of negative theta, well, cosine of negative theta equals cosine theta. So this is just cosine of 2x. And I'm done. Okay. Any questions at this point? Alrighty. So number 6 looks very much like a sum or difference for tangent. So I've got addition in the numerator, subtraction in the denominator. So that looks like the sum of the angles identity. So that means that this would give me tangent of 4 theta plus theta, again, showing my work. And then that's equal to tangent of 5 theta, and that's it. Okay. What questions do you have at this point? Anything? Good. All right, so look at number 7. Sine times cosine, cosine times sine. So that looks like one of my sine identities. There's subtraction in here. That matches the subtraction in the difference. So this is going to be sine of A minus B. So this equals the sine of pi halves minus alpha. Then that looks like something that we've seen before, right? If you look at your cofunction identities, you can find sine of pi halves minus theta. That's equal to cosine theta. So this would be cosine alpha. Easy enough? We good? Do what? You're confused with this one. Tell me why. Where did I confuse you? Because on your chart, I didn't make it up and it's not magic, if you find sine of pi halves minus alpha on your cofunction identities, does that make sense? Yes? Hi, thank you. David. It's for something else. But remind me to talk to you about what you asked me about Friday when we're done with this. Okay. All right, so does everybody get on number 7 now? Okay. All right, so now look at number 8. Looks very much like a tangent one, right? And so I've got subtraction in the numerator, addition in the denominator. So I'm pretty sure that's a difference. And then a double check that this is AB, AB. So I'm good. So that makes this tangent of y minus pi halves. Okay, so that looks a lot like this. But when you go and look at your cofunction identities, and that for the tangent, well, really for any of them, pi halves comes first. And it doesn't come first here. So that's a problem. We have to fix that, kind of like we did the other day. So I'm going to go ahead and change places here. So this gives me the tangent of negative pi halves plus y. So now pi halves comes first, but it's negative and the y is positive. So inside of that, I'm going to factor, and I'm going to get tangent of negative, parentheses, pi halves minus y. So what this gives me here, whatever pi halves minus y is, it's some angle. So this is tangent of a negative some angle, right? The pi halves minus y is just an angle, so it's like theta. So I can find on here tangent of negative theta. And tangent of negative theta equals what? Negative tangent theta. So this is going to be negative tangent, and it's not really theta. My theta is pi halves minus y. So now, I don't have a negative tangent of pi halves minus y, but I can find tangent of pi halves minus y, or at least theta on here. And when I find that, tangent of pi halves minus theta, that gives me cotangent theta. So that means this would have to be negative cotangent y. Bless you. What questions do you have? We all good so far? So there's your simplifying. So now we're going to do some proving. On number 9, once my board decides to cooperate, there we go. Now, usually I've said, and remember, every time I say this, I say usually, not always, but usually if you have a fraction, you probably want to work with the fraction. But I don't feel like there's a whole lot I can do with that fraction over there. I probably have to put something in there. So I'm actually going to work with the left-hand side now because I have something I know I can easily substitute in there for. So we're going to work with the left-hand side, and this is our goal. Okay? So I have a tangent. The sum of angles identity, the tangent of a plus b, right? So tangent of a plus b, so my a and b are x and pi fourths, and I'm just going to substitute it directly into this identity. That'll give me the tangent of x, that's my a, plus tangent of pi fourths, that's my b, over, then that's 1 minus tangent x times the tangent of pi fourths. Okay, and that's supposed to equal tangent of x plus 1 over 1 minus tangent x. So I'm going to remind you again, when you are proving, you write the entire equation out every single time. If you're not doing that, I'm not grading it. If I can't follow your thought process, I can't read what you wrote, I'm not grading it. Okay, so make sure that you have done everything that I've been telling you need to do. So I keep working with the left-hand side. Okay, so I can actually evaluate the ones that have the pi fourths in there. So tangent of x plus, what's tangent of pi fourths? 1 over 1 minus tangent x times the tangent of pi fourths. And since the tangent of pi fourths is just 1, I'd have tangent of x times 1, which is just tangent of x, so I'm not even going to write it. And that's supposed to equal, I rewrite my right-hand side, tangent of x plus 1 over 1 minus tangent x. Those now look identical, and I'm done. What questions do we have? Okie dokie. Number 10. Now, number 10 looks like maybe it's super easy, right? Because if you find secant of pi halves minus theta on your chart, it says it's equal to cosecant theta, so like we're done before we start, but not really. Because the purpose of this is to prove the identity, so you can't just say, well, it's right because it's on the chart. So we're actually going to use a sum or difference identity, which means we want it to look like this side, and we have to make them look equal anyway, and you can't just substitute it in that easy. I did that opposite, I'm sorry. I circled and underlined the wrong thing. Our goal is, I think I said the right thing, but then I did it backwards. That's our goal, this is what we're working with. So when you look at your sum and difference identities, you only have sine, cosine, and tangent. There's not a secant there. But this, whatever pi halves minus theta is, this is just some angle. So this is like secant of alpha. So what's the reciprocal of secant? Cosine, right? So that means that this cosecant theta is equal to 1 over cosine of pi halves minus theta. Okay. I have a cosine sum of angles thing I can use. So this is going to be cosecant theta equals 1 over, all right, so I find cosine of A minus B. I'm going to rewrite my, all of that is so crooked for some reason, so hang on. I think because I was trying to do it from this side. Cosecant theta equals, that's still crooked, but it's not as bad. All right, so I find cosine of A minus B, excuse me. So that's cosine of A times cosine of B. So this is cosine of pi halves times cosine of theta. And then, since this is a difference, that's a plus sine of pi halves times sine of theta. Everybody okay with where everything came from, right? I'm not making it up. There's no magic. I'm getting it right off the reference chart that I don't have memorized either because it's not necessary. You know, you only have room for so much important stuff. As long as you know how to use it, you're good. All right, so cosecant theta equals, so I've still got 1 over, we want to simplify this, cosine of pi halves. Roberto, what is cosine of pi halves? It's not going to be, you're giving me an angle. Cosine of pi halves. That's the angle. Where's pi halves on your unit circle? It's right there, right? So what's the cosine then? The cosine value isn't going to be a pi though. Think about that. If I'm here on my unit circle, I'm here at pi halves, what's that cosine value? Your cosine values are going to be like 1/2, square root of 3 over 2, square root of 2 over 2, that kind of thing, 0, 1. You got it. All right, so it's 0. So cosine of pi halves is 0 times cosine theta plus sine of pi halves. Andre, what's the sine of pi halves?
1.
You got it. It's 1, so we get 1 times sine theta. So that means that cosecant theta equals 1 over, well, 0 times cosine, that just zeroes out, plus 1 times sine, so that's just sine theta. That's where we get cosecant theta equals cosecant theta, and we are done. Okay. What questions do you have? Anything? Okay. If we look at number 11, I think we would agree that the left-hand side looks way yuckier than the right-hand side. But these are all just straight up sum and difference identities. You have sine of a plus b minus sine of a minus b. I mean, they're x and y, but it's the same thing, right? So on the left-hand side, go ahead and substitute the stuff in. Try and do it without just copying mine down, and I'm going to do it without saying it out loud. So use your chart, try to substitute it in, and then you can double check with mine, okay? Then once you're done just with the substituting part, double check with me. We started with 2 terms in the numerator and 2 terms in the denominator, and then we ended up with 4 terms in each. So parentheses are important. So remember, you end up in math jail. Where is it? Right here. I submitted more than 1 term and didn't use parentheses. It's a bad thing when you don't do that. Okay. Any questions about where any of my stuff came from? We're all good? All right, so I'm going to start cleaning it up. I'm going to start cleaning up the numerator first. So I have sine x cosine y, and here's sine x cosine y right here. So I'm going to subtract those 2, so those zero out. Then I have cosine x sine y right here, and cosine x sine y right there. Do those zero out? No, they do not. That's why those parentheses are important, because it's minus a negative. That actually gives me 2 of them, so that would give me 2 cosine x sine y. Then in the denominator, I have cosine x cosine y right here, cosine x cosine y right there. I'm adding them, so that gives me 2 cosine x cosine y. Then I have negative sine x sine y and positive sine x sine y. It's plus a positive there. So those zero out. So then that's supposed to equal tangent y. Okay. Any questions about where anything came from? All right, so now I can simplify on the left-hand side. The 2's cancel out. The cosine x cancels out. So that leaves me with sine y over cosine y. And that's equal to tangent y. And then we know that sine over cosine is tangent, so tangent y equals tangent y. And we are done. What questions do you have? Anything? All right. So we're not going to do number 12 because it uses double angles that we haven't looked at yet. And on your assignment, I don't know if I can get back to my calendar because all this stuff on my board's in my way. But you are omitting number 13 because it's like number 12. And we'll get to that stuff eventually, right? Any questions at all? Alrighty.